Hello everyone. Welcome to all of you in FFB Live Chemistry class. Now today's topic for your study is carbon family, that is group 14 elements. तो केमिकल रिएक्टिविटी के कि किस तरह से एलिमेंट टू एलिमेंट जो जितने भी मेंबर इस उसमें प्रेजेंट होते हैं ग्रुप 14 या कार्बन फैमिली में, उनमें किस तरह से ट्रेंड होता है आगे, कुछ डिफरेंसेस किस तरह से डेवलप होते हैं या उनमें सिमिलरिटीज किस तरह से होती है, यानी कि केमिकल रिएक्टिविटी के बारे में हम आज के क्लास में डिस्कस करेंगे। तो टुडेज टॉपिक इज केमिस्ट्री ऑफ ग्रुप 14, दैट इज कार्बन फैमिली एलिमेंट्स। क्योंकि कार्बन इसका पहला मेंबर है, तो इस ग्रुप को 14 ग्रुप को हम कार्बन फैमिली ग्रुप भी कहते हैं। Now trends in chemical reactivity of group 14. The elements of this group are relatively less reactive, but reactivity increase down the group. Lead often appears somewhat less reactive than expected. This is partly due to surface coating of the oxide and partly due to the high over potential for the reduction of H plus to H2 at lead surface. Carbon, silicon, and germanium are unaffected by water. Tin SN reacts with steam to give SNO2, stainless oxide, and hydrogen. Lead is unaffected by water, probably because of a protective oxide film on the surface. SN रिएक्ट करके SNO2 बनाता है और हाइड्रोजन लिबरेट होती है। Carbon, silicon, and germanium, however, decomposes steam or red heating, evolving hydrogen. Non-oxidizing acid do not attack carbon and silicon. Germanium is not attacked by dilute HCl. However, when metal is heated in HCl gas, germanium chloroform is formed. This is germanium chloroform when heated in HCl gas. Tin dissolves slowly in dilute HCl but readily in concentrate HCl. Tin dissolves in HCl to form stannous chloride and water. Lead dissolves slowly in dilute HCl. The reaction stops after some time due to deposition of lead chloride. In concentrate HCl, it forms chloroplumbous acid. This reacts to form lead chloride, and in excess or concentrate HCl, it forms chloroplumbous acid. This is H2PbCl4. Tin dissolves in dilute H2SO4, concentrate H2SO4, dilute HNO3, and concentrate HNO3. Like these reactions are here. Tin reacts with dilute sulfuric acid to form stannous sulfate and hydrogen. It reacts with concentrate sulfuric acid to form stannic sulfate and sulfur dioxide and water. It reacts with mixes of nitric acid, form stannic sulfate and ammonium nitrate and water, and it also reacts with concentrate HNO3 to form beta stannic acid HNO3 and nitrogen dioxide and water. Tin is not affected by organic acid. This property is utilized for tining cooking utensil made of copper or brass. Lead is not affected by dilute sulfuric acid. Hot concentrated sulfuric acid dissolves lead, but the reaction becomes slower due to formation of insoluble lead sulfate. तो lead sulfate insoluble होता है, कंसनट्रेट सल्फ्यूरिक एसिड के साथ डिजोल्व होकर ये लेड सल्फेट सल्फर डाइऑक्साइड और वाटर बनाता है। HNO3 is the best solvent for lead. Lead dissolved dilute concentrate dilute nitric acid to form lead nitrate, nitric oxide and water, and in concentrate excess of concentrate HNO3, it forms again lead nitrate and the यहाँ पे नाइट्रोजन ऑक्साइड नाइट्रिक ऑक्साइड और यहाँ नाइट्रोजन डाइऑक्साइड बनता है. Now organic acid dissolve lead in presence of oxygen. अनएफेक्टेड होता है ऑर्गेनिक एसिड से लेड, बट इन प्रेजेंस ऑफ लेड डिजॉल्व हो जाता है एसिटिक एसिड में और बनाता है लेड एसीटेट. Carbon is unaffected by alkali. Silicon reacts slowly with cold aqueous solution of NaOH and readily with hot solutions. Tin, Sn and Pb are slowly attacked by cold alkalis and rapidly by hot alkalis, giving stanates and plumbate. The reaction is here. Silicon reacts to NaOH to form sodium silicates. Tin reacts to NaOH to form stanate, and lead reacts to NaOH to form plumbate. Sodium plumbate, this is sodium stanate, and this is sodium silicate. Diamond does not react with the halogens, but graphite reacts with fluorine at 500 degree centigrade. Silicon and germanium reacts readily with all the halogens, forming volatile halides MX4. Tin and lead are less reactive. Tin reacts with Cl2 and Br2 in the cold and with F2 and I2 on warming, giving S and X4. X की जगह पे क्या हो सकता है F या I. Lead reacts with fluorine in cold, forming PbF2 and with Cl2 on heating and forming PbCl2. This is lead chloride. Some common chemical reactivity trends of the elements of group 14 are here. First, hydrides of the group 14 elements. All the elements of this group form covalent hydrides directly or indirectly. The number of hydrides, their stability, and the S of formation decrease as we move down from carbon to lead. However, all the members forms hydrides of type MH4. Besides CH4, this is methane, carbon forms a vast number of chain and ring hydride, saturated as well as unsaturated. These hydrides are termed hydrocarbon, the most common family of hydrocarbon. Alkane or paraffins, which are saturated, general formula CnH2n plus 2. Alkenes or olefins, these are unsaturated, general formula होता है CnH2n. And alkyne or acetylene unsaturated, general formula CnH2n minus 2. Benzene and its cyclic homologues, that is aromatic hydrocarbon, formed by the carbon and एलिसाइक्लिक हाइड्रोकार्बन. तो इतने कंपाउंड बनते हैं कार्बन के. The tendency of carbon to form large number of hydrocarbon is due to catenation property and multiple bonding, जो हम पिछले क्लास में डिस्कस कर चुके हैं. Silicon forms a limited number of saturated hydrides. SiNH2n plus 2 is the general formula called the silane. These may exist as a straight chain or bronze chain containing up to 8 silicon atoms. No analogues of alkenes and alkynes are known. Several germanium hydrides called germanes GeNH2n plus 2 are known up to n is equal to 5. Tin forms two hydride SnH4 and SN2H6. Only one hydride of lead is known. SnH4 and PbH4 are named stanane and plumbane. The hydrides of tin and lead are least stable. PbH4 is even difficult to prepare. The hydride of MH4 type are gaseous and their thermal stability decrease, and consequently the reducing nature increase from top to bottom. However, among the hydrides, silicon hydrides are less stable to hydrolysis. Hydrides डिकम्पोजिशन टेम्परेचर इनका मीथेन का सबसे ज़्यादा है 800 डिग्री सेंटीग्रेड। फिर सिलिकॉन हाइड्राइड SiH4 का है 450। जर्मेनियम के हाइड्राइड का है 285। इसी तरह इसका लगातार घटता जाता है, जबकि यहाँ पे डिकम्पोजिशन टेम्परेचर जीरो है, यानी कि ये फॉर्मेशन ही डिफिकल्ट होता है इसका। The hydrides of silicon are much more reactive than alkanes. The difference in behavior is attributed to various factors. First is electronegative values are C has a electronegative value 2.5, silicon 1.8 and H 2.1. Thus the bonding electron between C and H or Si and H are not equally shared, and silicon is vulnerable to attack by nucleophilic region। इस तरह से कार्बन ये बनाता है यहाँ पे C-H+, और लेकिन सिलिकॉन क्या होता है, अट्रैक्ट कर लेता है अपने तरफ हाइड्रोजन यहाँ अट्रैक्ट कर लेता है और ये हाइड्राइड बनाता है, और इस पे जो है माइनस चार्ज और इस पे प्लस चार्ज डेवलप करता है। तो दिस इज द डिफरेंस बिटवीन कार्बन एंड सिलिकॉन। द लार्जर साइज ऑफ सिलिकॉन इज easier to be attacked. Silicon has low energy d orbitals which may be used to form an intermediate compound and thus lower the activation energy of the process. SiH4 reacts with NaOH H2O to form sodium silicate, and SiH4 reacts with water to form H2SiO3 plus H2, and it reacts with silver nitrate to reduce the silver nitrate to silver and form HNO3 and silicon also reduced, and this reacts with chlorine to reduce SiH4 and form HCl. The low stability of GeH4, SNH4 and PbH4 is due to weak MH bond. It is due to large difference in the size of M and hydrogen atom, leading to poor overlapping and weak covalent bond. Now some point to be noted. Extremely pure silicon can be obtained by pyrolysis of monosilane. SiH4 in absence of air. The pure silicon is used as a semiconductor. सिलिकॉन क्लोराइड टेट्राक्लोराइड को लिथियम एल्युमिनियम हाइड्रोक्साइड से गर्म करने पे पहले ये SiH4 में बदलता है, फिर हीट करते हैं इनको एब्सेंस ऑफ एयर में, तो से प्योर सिलिकॉन मिलता है। नाउ सेकंड टाइप ऑफ कंपाउंड इज हाइलाइट्स। The element of group 14 form tetrahalides. The formula MX4, that is PbCl4 and PB. mm, the PbCl4 and lead tetrachloride and lead tetrabromide are unstable, while lead tetraiodide is unknown. All these halides are covalent and formed by sp3 hybridization. That is, these have tetrahedral shape. These halides are very volatile. The exceptions are SNF4 and PBF4, which have three-dimensional structure. Non-existence of PbI4 can be explained on the basis of a strong oxidizing nature of Pb4 plus ion. The iodide ion are reducing in nature, and these reduce Pb plus 4 ion into Pb2 plus, then ये रिड्यूस करके खुद आयोडाइड में कन्वर्ट हो जाता है, आयोडीन में कन्वर्ट हो जाता है, ये Pb2 प्लस आयन बनता है। द सेम एक्सप्लेनेशन कैन बी गिवन फॉर इंस्टेबिलिटी ऑफ PbBr4. The thermal stability of halides of different elements with a common halogen decrease with increasing atomic number. The thermal stability of tetrahalides of the same element decrease with increase in molecular mass of the tetrahalide CH4 SiH4। उसी तरह से क्या है ये थर्मल स्टेबिलिटी ऑफ टेट्रा हाइलाइट्स ऑफ द सेम एलिमेंट डिक्रीज विद इंक्रीज इन मॉलिक्यूलर मास ऑफ द टेट्रा हाइलाइट। दिस इज द trend. The carbon halides are not hydrolyzed under normal condition, while halides of other elements are readily hydrolyzed by water. The process of hydrolysis become more and more difficult to moving down the group. Carbon halides are not hydrolyzed by water because carbon has no d orbitals and cannot expand its coordination number beyond 4. However, silicon and other members have co-vacant d orbitals and can expand coordination number beyond 4. Thus, the halides of silicon and other members undergoes hydrolysis like this and form silicic acid, siliceous acid. The mechanism of hydrolysis of silicon tetrachloride with water is given as सिलिकॉन टेट्राक्लोराइड, चार क्लोराइड इस तरह से है। H2O से रिएक्शन करके यहाँ पे ये Si के साथ इस तरह से ये H2O मॉलिक्यूल इधर जुड़ गया है, ये इलेक्ट्रॉन अपना डोनेट करते हुए, और इधर ये इधर जुड़ गया है। और यहाँ से क्या होता है, दोनों के रिएक्शन में 2HCl अलग हो जाता है, और आगे फिर ये क्या मिलता है, दो जो Cl है वो OH से रिप्लेस हो गए, फिर आगे रिएक्शन होते हुए ये प्लस जब वाटर से रिएक्शन कराते हैं तो इस तरह से यहाँ पे सिलिकॉन से ये दो वाटर मॉलिक्यूल्स इस तरह से डोनेट कर रहे हैं इलेक्ट्रॉन, तो फिर यहाँ OH जुड़ जाता है और CS रिप्लेस हो जाता है, तो इस तरह से चारों क्लोरीन एटम है वो हाइड्रोक्सिल आयन से रिप्लेस हो जाते हैं। Carbon does not form dihalides. All the other elements do form dihalides like SiX2 type. This is a steady increase in the stability of dihalides. अब सबसे ज़्यादा stable कौन सा होता है? Lead dihalide. Oxides. The elements of group 14 form two types of oxide, dioxides and monooxide. Dioxides all form dioxide of type MO2. CO2 is a gas while SiO2, GeO2, SNO2 and PbO2 are crystalline solid with high melting points. These oxides differ in their structure and properties. Carbon dioxide is a linear molecule. Carbon forms p pi bond with oxygen, C double bond O, has one sigma and one pi bond like this। इसमें डबल बॉन्ड है, एक सिग्मा एक पाई बॉन्ड होता है। इस तरह से इलेक्ट्रॉन की दो इलेक्ट्रॉन की शेयरिंग दोनों तरफ होती है। Carbon dioxide with the above structure predict that bond length in the molecule should be equal to double bond, that is 122 pm. However, experimentally, the bond length has been measured and it has been found to be 115 pm. That pm means picometer. This shows that the molecule of CO2 is a resonance hybrid of the following structure. तो ये तीन तरह की स्ट्रक्चर इसका रेजोनेंस हाइब्रिड होता है कार्बन डाइऑक्साइड। सिलिकॉन डाइऑक्साइड इज ए सॉलिड, इट हैज ए गैंट स्ट्रक्चर इस तरह से SiO2 इस तरह से आपस में ये जुड़ करके गेंट स्ट्रक्चर इस तरह का बनाते हैं। दिस इज द स्ट्रक्चर ऑफ सिलिका। Silicon is tetrahedrally bonded to 4 oxygen atoms and each oxygen atom is bonded to 2 silicon atoms by covalent bond, hence silica has high melting point। इस तरह की स्ट्रक्चर ही रिस्पॉन्सिबल होती है इसके हाई मेल्टिंग पॉइंट के लिए। Other dioxide, GeO2, SnO2, and PbO2, are also crystalline solids with three-dimensional network structure. In this structure, the metal has coordination number 6. Each metal atom is octahedrally linked to 6 oxygen atoms. The acidic nature decreases with increase of atomic number. CO2 and SiO2 are acidic, while GeO2, SnO2, and PbO2 are amphoteric. All these dissolve in alkalis, giving carbonates, silicates, germanates, stannates, and plumbates respectively. The reaction is here. MO2, यहाँ पे कोई भी मेटल इनमें से हो सकती है, NaOH से रिएक्शन करके इस तरह का कंपाउंड बनाती है. तो dioxide of germanium tin lead also dissolve in acid. Germanium oxide dissolved in acid to 5GeCl4. Stannic oxide dissolved in HCl to form stannic oxide. This is stannic oxide. And lead oxide reacts with HCl to form lead chloride, Cl2 and H2O. PbO2 is a powerful oxidizing agent. Now monoxide. All the elements form MO oxides. All are quite stable except SiO and GeO. Carbon monoxide is a neutral in nature while other oxides are amphoteric. Carbon monoxide is a colorless, odorless poisonous gas. The poisonous nature is due to its reaction with hemoglobin to form carboxyhemoglobin, which is not capable of absorbing oxygen, and thus oxygen not carried round the body by blood. Carbon monoxide is an excellent ligand as it can donate an electron pair to many transition metals, forming carbonyl compounds such as NiCO4, FeCO5, CrCO6. The bonding in carbon monoxide is represented as दो दो इलेक्ट्रॉन का शेयर होता है इसमें, और एक पेयर इलेक्ट्रॉन जो है ये ऑक्सीजन कार्बन को देकर के कोऑर्डिनेट बॉन्ड बनाता है. तो इस तरह से बॉन्ड स्ट्रक्चर कार्बन मोनोऑक्साइड की इस तरह से होती है. Lead oxide is commercially important. It is known in two forms. The red form is called litharge and yellow form is called Mesicot. SNO and PbO dissolve both in alkali and acids. SNO dissolve in NaOH to form sodium stannate, and lead oxide dissolve in NaOH to form sodium plumbite. SNO reacts with sulfuric acid to form SnSO4, and lead oxide reacts with sulfuric acid to form lead sulfate. Now, abnormal behavior of carbon. Carbon is the first member of the group 14. It differs markedly from rest of the member of group 14, and this anomalous behavior is illustrated by the following headings. First, small atomic radius and high electronegativity. Carbon, being the first member of the group 14, has the smallest atomic radius and highest electronegativity. It is typical non-metal. On account of this, it has higher ionization energy among the group 14 elements. It is most compact. It is the hardest element that has higher melting and boiling points compared to the rest of the members. Now, catenation. It has maximum property of catenation as the bond energy of CC bond is very large, that is 83 kilocalorie per mole or 355 kilojoule per mole. It can form long chains, straight or bronze or rings of different size and shapes. The another property of the carbon is formation of multiple bonds. Carbon can form carbon can form multiple bonds pi with itself and with other elements such as NO, etc. The multiple bonds such as C double bond C, C triple bond C, C double bond O, C triple bond N, C double bond S. etc., are frequently found in carbon compounds. By virtue of this property and property of catenation, carbon forms a very large number of compounds. Now, maximum covalency. Carbon shows a maximum covalency of 4. However, silicon and other higher members of the group can show maximum covalency of 6 due to availability of d orbitals in their valency shell. The d orbitals are not present in the valency shell of carbon. As a result, silicon and other higher members permit the formation of coordinate bond with other atoms or ion having lone pair of electron. Like this, carbन does not form such ion or complexes. अदर एलिमेंट जो है इस तरीके से कॉम्प्लेक्स आयन बनाते हैं. The tetrahydrides of carbon do not undergo hydrolysis, while those of other elements of the group undergo hydrolysis. Carbon dioxide is a gas, while dioxide of other elements are solid. Now, dissimilarities between carbon and silicon. फर्स्ट इधर कार्बन और इधर सिलिकॉन के बारे में है. कार्बन हैज 2 इलेक्ट्रॉन्स इन द पेनल्टीमेट शेल. 2 4 इलेक्ट्रॉनिक कॉन्फ़िगरेशन होता है इसका. बट सिलिकॉन हैज 8 इलेक्ट्रॉन इन द पेनल्टीमेट शेल. पेनल्टीमेट शेल मीन्स बाहर से अंदर वाली शेल को पेनल्टीमेट शेल कहते हैं. कार्बन is a black solid, it does not melt. But silicon is a reddish brown solid, it melts at 1410 degrees centigrade. Carbon have some allotropic forms of carbon, that is graphite, are good conductors of electricity. Silicon is a bad conductor of heat and electricity. Carbon, caustic alkalis have no action on carbon, but silicon reacts with alkalis to form evolve hydrogen like this. Fifth point is the dioxide. Carbon dioxide is a gas. It has a linear structure. Carbon atom is linked to oxygen atom by double covalent bonds. Carbon in sp hybridize. These hybrid orbitals overlap with the p orbitals of each oxygen atom. The remaining two p orbitals of each oxygen atom form pi bonds with p orbitals of carbon atom. O डबल बॉन्ड P से P पाई बॉन्ड होता है और साथ में पी एस पी सिग्मा बॉन्ड होता है यहाँ पे. APP एक पाई बॉन्ड होता है, पीपी बॉन्ड, और ये पी एस पी क्या है, ये सिग्मा बॉन्ड. द कार्बन डाइऑक्साइड molecules are held together by weak van der Waals forces. Hence, it exists as a gas at ordinary temperature. Carbon dioxide dissolve in water and behave as a weak acid. It dissolves in water to form carbonic acid and reacts with NaOH to form sodium carbonate. On the other hand, dioxide silica is a solid SiO2. It has a straight gained structure. The silicon atom is linked with oxygen atom by single covalent bond like this. Silica has a three-dimensional infinite structure इस तरह से, in which silicon is tetrahedrally bounded to 4 oxygen atom, and each oxygen atom is bonded to 2 silicon atoms इस तरह से by covalent bonds. Hence silica has high melting points and is a solid. Silica is insoluble in water and acts as a very weak acid. It reacts with sodium hydroxide to form sodium silicate. The lower oxide, the carbon monoxide, is known. It is stable and neutral in nature. Lower oxide, this is carbon monoxide is a lower oxide. At SiO of silica is unstable. It forms a large number of hydride known as hydrocarbon which are stable, these are not hydrolyzed by water. Silicon forms lesser number of hydride which are not very stable. These act as reducing agent. These are hydrolyzed by water with evolution of hydrogen. The reaction is here. It reacts, carbon does not react directly with Cl2 or Br2, but silicon reacts with Cl2, Br2 at 500 degrees centigrade to form silicon tetrachloride. The carbon tetrachloride is a stable compound and is not hydrolyzed by water. This is the property of carbon compounds. The hydrolysis does not occur because water molecule cannot be coordinated to carbon at its maximum covalency is 4. In silicon, silicon tetrachloride is less stable and is hydrolyzed by water. The hydrolysis is due to the fact that water molecules can be coordinated to silicon as its maximum covalency is 6. In carbon, the oxy acid H2CO3 is unstable. This is carbonic acid. It is best known in the form of salt and carbonates. But oxy acids of silicon H2SiO3 is stable. It is also known in the form of salt silicates. Carbon does not form complex ion as d orbitals are not present and maximum covalency is 4. But silicon forms a number of complex ions as d orbitals are present and maximum covalency is 6. Now this similarities with tin and lead. This similarities between tin and lead. Here is the tin and here lead. Tin means SN, स्टेनस या स्टेनिक भी कहते हैं इसको. Tin shows allotropy, but lead does not show allotropy. Tin does not leave any mark in paper. Lead leaves a mark on paper. Tin is a ductile, but lead not very ductile. Tin is a metallite, lead is a metal. SNO does not combine with silica, but PbO combined with silica, showing PbO is more basic than SNO. It forms lead silicate. SnCl2 is soluble in both dilute and concentrated HCl, while PbCl2 is insoluble in dilute HCl but soluble in concentrated HCl, forming complex like HPb3, H2PbCl4, etc. Stannous sulfide is soluble in yellow ammonium sulfide, showing its acidic nature, but lead sulfide is insoluble in yellow ammonium sulfide, showing its basic nature. Now, stannic compounds are stable. Stannous compounds act as reducing agent. Plumbous compounds are stable. Plumbic compounds act as a oxidizing agent. Tin is not attacked by organic acids. The reaction is not retarded with sulfuric acid as sulfates of tin are soluble. As tin forms metastannic acid with concentrated nitric acid, but lead dissolve in organic acid. The reaction with sulfuric acid is retarded by the formation of insoluble lead sulfate. Pb forms lead nitrate with concentrated nitric acid. Now tin combined with sulfur to form stannic sulfide and lead combined with sulfur to form lead sulfide. So these are the chemistry, total chemistry of group 14 of carbon family element. इसमें सारी मेटल्स किस तरह की रिएक्शन शो करती हैं और किस तरह से उनमें सिमिलरिटीज़ है, कहाँ कहाँ डिससिमिलरिटीज़ है, सारी चीज़ें यहाँ डिटेल में डिस्कस हुई है, जिससे पूरे ग्रुप के बारे में एक अच्छी जानकारी तुम्हें मिल गई है. अब आगे के क्लास में हम कंपाउंड्स ऑफ कार्बन, कंपाउंड्स ऑफ सिलिकॉन, इस तरह की चीज़ें डिस्कस करेंगे.